Hi, my name is Gierbolini. I'm from the University of Puerto Rico, and today I'm going to be presenting my summer project about making DNP and MR better. Why do we care about DNP and MR? Well, first of all, NMR is a technique that determines the chemical structure of compounds, and it's widely used for different applications. DNP allows NMR spectra to be obtained 10,000 faster and better, and it has helped us to discover new things. And one example of this is the quantification of tin present in toothpaste. Did you know that tin fluoride is the active ingredient that prevents gingivitis? Well, this is thanks to the tin 2 present in toothpaste. However, this tin 2 can be easily converted to tin 4 when we leave the caps open of our toothpaste. We know this information because researchers have used DNP and MR to make this happen. But how exactly does DNP and MR make this happen? Well, DNP uses polarizing agents as biradicals that have lone electrons, and it uses microwave irradiation to saturate those electrons and do a polarization transfer to the protons and then to the desired nuclei. If we were to do a glycerol spectra, we will get a spectra like this. But when we do it with DNP and MR, we're basically putting steroids on the signal and enhancing it to this. Recent studies conducted by my mentor, Amit Venkatesh, show that actually hydrofol and NaFol provided the overall sensitivity for both aqueous and organic solvents at 9.4 Tesla. With the resources here at the MagLab, our question is, how exactly those biradicals perform at higher magnetic fields? To answer this question, we did a systematically evaluation where we dissolve a list of biradicals in aqueous solutions and pack those solutions into the probe of the MAS DNP 14 Tesla magnet at the MagLab. And after taking the measurements, they were analyzed by us. We took into consideration 3 parameters. One of the parameters being the enhancement, where we evaluated the signal intensity ratio between the microwaves on and the microwaves off. We did this for both deuterated and protonated water. As you can see, in protonated water, we have less enhancement, and this is because it has more protons, so it is a larger surface to polarize. We also measured the buildup time, that is how long it takes the DNP to achieve that higher intensity signal. We have a simple puck that has a lower buildup time, and we have amupol that has a lower buildup time, higher buildup time, sorry. We also calculated the contribution factor, that is the intensity that gets effect in the microwaves off intensity, because by the incorporation of the radical in the solvent, some of the intensity can get lost. With these 3 parameters, we were able to calculate the overall sensitivity using this formula. As you can see, we have hydropol, the one that studies show that it was the better, and now we have SNAPple that is 2 times better. That means that experiments that took 4 days now only now can take 1 day. We did this work in collaboration with the MC group in Switzerland, and they did the measurements for 9.4 Tesla and 21.1 Tesla. And if you look closely, they all have one thing in common, and that's SNAPple. So we can conclude that we have found that SNAPple provides the best sensitivity for the 3 magnetic fields desired, and in the future, we will continue this work in organic solvents. I would like to acknowledge my mentor, Dr. Amit Venkatesh, and my co-mentor, Dr. Faith Scott, to the amazing researchers here at the MagLab and at Switzerland, and to our REU mentoring director, Dr. Kawana Johnson, for this amazing experience. Thank you so much for everyone.